Hello guys, welcome to Code with BK. So in this video we solve the problem to check if an integer is an Armstrong number or not. So in the first half I'm going to explain you the process, the steps to solve this problem, and in the second half we are going to look at the codes, the implementation part. So if you are someone who's just looking for codes, there are links to the codes in the description of this video, and to each link there is a text explanation as well. So if you are somebody who wants to read and understand, you can take a look at that as well.
Please do not forget to subscribe to this channel and click on the bell icon to receive all the latest updates.
So what is an Armstrong number? Suppose we have an integer k of n digits. Taking an example of 153, you pick up each digit separately and raise it to the power to the number of digits in this original integer, which is 3, and add all of this. So 1 cube is 1, 5 cube is 125, and 3 cube is 27. If the sum of all these is equal to the original value k, then this integer is an Armstrong number. Let's consider another example. So we have, say, 1634. So this has 4 digits. So n is 4 in this case. You pick up each digit separately, raise it to power of 4. So this is 1 plus, this is 1, 2, 9, 6, 36 into 36, plus this is 27, 3 are 81, plus 256 to the power 8. So if you calculate the total of this comes out to be 1634. So 1634 is an Armstrong number. We solve this problem using two separate methods. We use strings in the first method and while loops in the second method. So let's look at the first method. So I'll add a function. It'll say is Armstrong number, takes in an integer k. This will return true if this k is an Armstrong number, else it will return false. So the first task is to find n, which is the number of digits in this integer k. I've already posted a video to find number of digits in an integer, and since we are using strings, it is very simple. We simply convert this k to a string and then find the length of that string. So I'll say kstr is basically string form of integer k. Then n will be length of this kstr. So next what I have to do, I have to pick up each digit from this integer. Now I have this integer in string form. So basically what I do is I iterate the string and pick up each character, which is basically my each digit in k. So what I do is I do for I is equals to 0 to I is less than n. Iterating the string. So the ith character is going to be kstr of I. So c is a character here which is at index I in this string kstr. You have to convert this character c to its corresponding digit. So I'll say to integer c. So convert c to an integer into its corresponding digit d. So in each iteration I get digit d, which is basically a digit in this integer k. I have to raise this digit to the power number of digits, which is n. So I have to basically calculate d to the power n, and then I need to add it to a sum. So I'll take a sum starting at 0. So sum is sum plus power of d to n. So power is a method that calculates d to the power n, and we have this method in our programming languages, so we don't need to write this separately. Finally, the last check, if this sum is equal to our original value k. So if s is equals to k, you return true, else you return false. So this is how we check if an integer is an Armstrong number or not. And since we are using strings, our job is very simple here. So let's run this algorithm for k is equals to 153. So k takes value 153. So kstr is string form of this integer, which is 153. N is length of this string, which is 3. S is set to 0. So I have value I, C, D, D to power n, and S. So I takes value 0 to less than n. So I takes value 0, 1, and 2. Less than 3, 0, 1, 2. C takes value for I is equal to 0, take str of I, which is this character at index 0, which is 1. D is integer form of C, which is 1. D to power n is 1 to power 3, which is 1, and S is S plus D to power n, which is 1. I takes value 1. So C is character at index 1, which is 5. D is integer form of this character, which is 5. d to power n is 5 to power 3, which is 125, and s is s plus this value d to the power n. So 125 plus 1, 126. I takes index 2, c is 3, then d is integer form which is 3, d to the power n is 3 to the power 3 which is 27, s is s plus d to the power n, 27 plus 126, 153. You come out of this for loop, you check s equal to k, s is 153, k is 153, you return true. So this is how you check for Armstrong number. It is easier and it is always recommended that you use an easier method. Let's move on to another method where we use while loops. So again we take a function that takes an integer k and returns true if this is an Armstrong number, else it returns false. So our first task is to find n, which is the number of digits. Okay, we cannot use strings. So we use the while loop method to find the number of digits in this integer k. I've already posted a video on how to do that. I'm just going to write the pseudocode for that. So this is the pseudocode that finds the number of digits in an integer n. So in our case, n is get num digits and you pass k. So please don't confuse this n with this n. This function takes n as its parameter. Okay, you can change the variable name. Okay, this n is the return value from this function. So this n is the number of digits. Okay, and we are passing k to this function. Second task is to break this integer into digits. Okay, I've already posted a solution for that as well. You can check that out. I'm going to use the pseudocode from that to break integer into digits. So this is the pseudocode that extracts digits from this integer k and stores them into this array digits. The digits stored in this array are in reverse order. Okay, for example, if you have 153, right? So digits stored in array are 351. Okay, this digits array is of size n because there are 3 digits. Okay, and then you print this array in reverse, so you print 153 after the while loop ends. In our case, all we need to do is find d to the power n for each digit d. So we don't need to have this array or store these digits into the array. Okay, I start with sum as 0. Okay, and I simply do sum is sum plus power of d to the power n. And this is something I don't need. I don't need to print digits. Okay, and then I simply check if s equal to k, return true. Okay, else return false. Also, k goes to 0 after this while loop ends because stopping condition is when k goes to 0. So you set k back to temp because before the while loop starts, temp stores a copy of k. Alright, and you don't need this either. So what we were doing was we were extracting digits and storing them into array. We don't need to store digits, we just need this digit one by one, and we keep adding d to the power n to this recurring sum. Okay, and then we compare this sum with k and check if this is Armstrong number or not. So let us dry run this code. So I have k as say 1634 this time. I get n as number of digits in k, I get n as 4. S is set to 0. So let me clear this so that I can have some space here. So I have temp, okay, this stays at 1634, sorry, because it is set to k. I have the value k, okay, which starts at 1634. I have this condition k not equal to 0. Then I have d. We start here with this while loop, k not equal to 0, 1634 is not equal to 0 is true. So d is k percent 10, k percent 10 is 1634 percent 10, which gives you 4. Then you do k is equal to k by 10. This is integer division by 10. So integer division 1634 by 10 gives you 163. It gives you the quotient. You miss out the remainder, so you get 163. Then you do s is equal to s plus power d to the power n. So d to the power n is going to be 4 to the power, what is n? 4, which is 256. Okay. So s was 0. You add 256 to 0. It becomes 0 plus 256 is equals to 256. You go back to check for the while loop condition, k not equal to 0, 163 not equal to 0 is true. You do d is k percent 10, 163 percent 10 is going to give you 3, the last units digit. Then you do k is equal to k by 10, integer division of 163 by 10 will give you 16. Then you calculate d to the power n, so 3 to the power 4 is 81. Then you do s is s plus d to the power n, so 81 plus 256, 337. You go back to check for while loop condition, k not equal to 0, 16 not equal to 0 is true. You do d is k percent 10, 16 percent 10 is going to give you 6, k is k by 10, 16 integer division by 10 is going to give you 1, d to the power n, 6 to the power 4 is going to give you 1296. You do s is s plus d to the power n. So 1296 plus 337, 1633. Alright. You go back to check for while loop condition. K not equal to 0 is true, 1 not equal to 0 is true. D is k percent 10, 1% 10 is going to give you 1. K is equal to k by 10, 1 by integer division 10 is going to give you 0. 1 to power 4 is going to give you 1. S is s plus d to power n. So this is 1633 plus 1, it is 1634. Alright, you go back to check for while loop condition. K not equal to 0 is false. Okay, you come out of the while loop. You set k to 10. K now becomes 1634. Okay, so if you were not doing this, if you were not setting k back to 10 where 10 was the original value of k, you would be comparing 0 with 1634, so you get wrong answer. So now k is 1634 and you compare it with s and k are equal, so you return true. Okay, so 1634 is an Armstrong number. So I hope this video was helpful. So please do like this video and subscribe to my channel, and let's move on to checking the codes now.
So this is the implementation of the first solution we discussed. So I've written a function is Armstrong number that takes an int k and returns a boolean value true or false. True if this k is an Armstrong number, false otherwise. So in this method we are using strings, so we convert k to its corresponding string. The length of this string kstr is now the number of digits. We take a sum equal to 0, we iterate the string, we pick up each character at the ith index, which is c, and then we convert c to its corresponding digit. So this is a standard trick to convert a character which stores a digit to its corresponding int value. Then we add to the sum d to the power n, and finally we check if s equal to k. So in our main we are checking 4 integers for Armstrong number. So let me run this java c Armstrong number 1.java Armstrong number 1. Alright. Moving on to the alternate implementation where we use while loop to extract the digits of an integer. So this is the first helper method that takes an integer n and returns the number of digits in this integer n. Taking the case for n equal to 0 separately in this case where we simply return 1. Again, writing a method is Armstrong number that takes an integer k and returns true or false based on the fact if this k is a Armstrong number or not. We use the helper method to get the value of n. We store temp to k and then we use the while loop method to extract the digits. After extracting each digit, we calculate d to the power n and add it to our recurring sum, setting k back to temp and then checking if s equal to k or not. Again checking for Armstrong number with the same 4 cases. So let me run this. This is 2 and 2. Alright. So I hope this video was helpful. So please do like this video and subscribe to my channel. And please let me know in the comments if there is anything not clear to you in this video, if there is a concept you want me to discuss, or if there is a question you want me to solve. Thank you.